here from the School of Engineering and Computer Science, as we're now called. Don't turn that into an acronym. But most of you will know me maybe from my blog livingwithdragons.com, which was when I really got into OpenStreetMap. I moved to Durham for university and started mapping quite detailed. As my undergraduate project, I then had to use OpenStreetMap, really, because I had made the data. So I was in the computer science department, as I said, so not so much on the geography, but we all know geography is important. When you describe somewhere, the terrain's also important. So I've got some questions up there, some phrases of talking about somewhere up there. They often sort of talk about going up a hill or something. But the problem is flat maps. Maps are flat. Even these two are flat. They've got contours or even hill shading, but the contours and hill shading can get in the way of the map features or the other way round. To know which is higher or which is lower, you kind of have to look at the values, and that can be hard because they're not always shown. I was going to say globes are even flat because they don't show the hills. But in Vienna here, there's the world's only globe museum, and out of the hundreds of globes, there were 2 that aren't flat, in my opinion. But go there and see them yourself. One solution is to make big models. This has been done for centuries. From sort of military use to tourism use, and here in developing countries with participatory GIS. But the trouble is, it takes a lot of time to make, and you're restricted with what's shown by what you paint on. If you decide you want to show a new river or you want to show schools, you have to paint it on, and then you're painting over something else. Perhaps. So computer science, let's throw a load of computers at it. We can do 3D graphics or virtual reality, but that kind of takes you out of the norm, what you're comfortable with. The users will probably focus on the technology rather than the topic you're talking about, and it's restricted usually to one person, either viewing it or controlling the view, what angle you're seeing it at. So what did I do? Well, I made a white model. It's a 3D model. It's actually bumpy steps, and it's a bit big. I did it, well, 20 inches by 30 inches, but too big to take on the train here. So I've got a prototype if you want to see that. So I've got the white model there that was quick to make, and then putting a projector above the model that's on the table, we can control with a computer what's displayed and turn on and off features. And so if we go into, we've got the interface to control what the projector saw. There's a list of layers essentially that you can show and hide, and you can change the order. If they're vector layers, you could change the color even, or the thickness to make something really stand out if it's important with what you're talking about. So that's one of the views of the maps. I had to make it quite colourful and bold, so things were different for users that don't normally use GIS. And also the resolution of the projector I used, it was a bit hard to see the text, so it had to be big. So that's kind of what the model looks with something projected on it. There we've got the river and the forests. It's a bit hard to get the idea without actually showing you it. So to evaluate it, I got groups of people in groups of sort of 2 to 4 participants. They answered the questionnaire, then I gave them a session to do, and then they answered another questionnaire. In total, I only had 5 groups, made out of 15 participants. So yeah, so after they had done the first questionnaire, I gave them they either had the model in place to start with, or they didn't. It was just projecting on the table and it was flat without the hills. And I gave them an envelope of 4 questions to answer and discuss in their group to find the best answer. I tried to make the questions so that there was no right answer, and they had to debate it amongst themselves. Yeah, so there's some of the questions. It was things like, which is the highest college in the university? What would be a nice route to walk from point A to point B? And so once they had done 4 questions, I gave them the other way. I either put the model there or I took it away and gave them a different set of 4 questions to see how they did the other way. So this is the groups we had. Unfortunately, as I said, I only got 5 groups. So you can see sort of, for example, question pack A, people only answered the questions in pack A with the model. So I can't really compare times or things with how they did without the model. And I felt that questions would cause different lengths of time, obviously. So I kind of ignored question pack A and C for the timings in these graphs. So there's my first graph. This is the time it took between them reading the question out and deciding on well, not even deciding on an answer, suggesting an answer to their friends. So if it was, for example, which church is higher, if someone goes, that one, then that's their first answer. Even if then they go, actually, I'm not sure. So yeah, so it was longer without the model. Generally, the main things that stand out are question B3 and D3. They were both about what route would you take between 2 places. So it's longer answers. It takes longer to even think about one answer because there's so many routes you can take. But really the model's been quicker because people can see they want to avoid hills or they're going to have to go up a hill anyway. So what I also liked most of all was the number of answers people gave, discussed, was sort of always either equal or there were more answers when they had the model in place. And so eventually they would settle on at least one answer or maybe 2. But it kind of suggests that without the model, they might have been not even considering a certain answer. And you could say that answer's not the right one anyway, so they were faster. But I think it's best when you've got a problem in front of you to think of all the possible answers. You don't want to be missing one. So yeah, except the only exception is D2 on there, which was which route did you take to get here, and that's quite a definitive answer. It's hard to argue and say, no, you didn't take that route to someone. So there's the total time spent. Yeah, and this is how long they took till they finally agreed on something or gave up and said it's too confusing, there's 2 answers. It doesn't tell us a lot. It's kind of hard to look at that just on its own. So what I then did is the time per answer that it takes, so dividing it by the number of answers they considered. And you can see without the model, they're not thinking of many answers, but they're taking a long time to discuss it. And then, so after they had done these sessions, I asked them some questions about how they felt. This graph kind of shows on various aspects, what did you think was easier? On the right hand, you've got that it was much easier with the model, or somewhat easier. On the left-hand side, you've got without the model. So they're being kind to me and going generally in the model's better way. But there were some things. Routes were, which is the green, were kind of, it goes off that maybe that without the model is better. I think that's a perceived thing, which that the model doesn't have much effect when you're planning routes. I'll argue that later. But yeah, so the model, they also answered some more open-ended questions that the model aided in imagining views, and sort of just seeing relating to places they knew, getting the overall picture, and yeah. So also one comment that that quite a few people said about without the model when it's just projected onto a white table is it's just like a normal map. I was like, yes, that supports that. It's a good comparison that I did. So yeah, someone also said that there's sort of extra effort required without the map. And one person admitted that they thought they got some answers wrong without the model, yeah, and someone else said, I think without the model it was more open to imagination. So I'll move on to conclusions, and so here I've got with the model, it was better for group work, which is sort of what I was hoping to achieve and looking at. They talked between each other a lot more. There was a lot of touching and pointing. One I liked is when trying to work out which was higher, and they had thought of 2 places. One person actually counted the levels and kind of went down the steps, and kind of went, well, 1, 2, 3, and then going up, 1, 2, 3, 4. Ah, that one's higher, which you can sort of do with contours, but I think people are less sort of happy just touching it. And I mean, yeah, so they actually touch it. Sometimes they knocked it out of place with the projector. But yeah, so planning and discussing routes, it seemed that they were doing better. I think it was actually a lot of people used local knowledge as well. And so they felt they had the right answer, but where the model helped was sort of explaining the answer they had to the other people in their group and sharing their information. So even if it's not giving them the best answer, or they don't think it's helping with routes, it's just that sharing of what you think. As I said, it gave an overall picture, and they considered more answers. So without the model, it took longer to get the first answer. They weren't so talkative. The places they had been, it was hard relating to where they had been, where it is on the model, even though without the model. Again, more time, and as I said, it's open to more imagination and comparable to either a flat paper map or even one on a computer screen. Some things I learnt was sort of the ability to turn on and off layers was new to people. I had to quickly put this diagram in the paper for my degree, because even my supervisor was like, well, what's the benefit? What do you mean that you can sort of, if you have one feature in front of another, it might cover up the others, and when you change the order, it sort of you get a different result essentially. And so yeah, people are just used to things like Google Maps. You're stuck with a flat map. If something's clustering up the map, you can't hide it on Google Maps. And that's what my project looked at to help with that. Yeah, so there was also, I had some time constraints for my project, because I'm an undergraduate, I've got to go to the bar as well. Further stuff that I'd like it to be looked at. I think there was no feedback for the user, no control of the layers. There was sort of a computer at the side of the room with the interface to change the layers. I think maybe if you had an iPad or something, it might help easier if they've got more access themselves and easier, and sort of a tablet PC you can still put down, so you're still not held to a computer, or maybe using cameras to detect movement, to detect actions, to change layers or move things. Perhaps if you were, one of the uses could be planning for a new site of something, if you can move a pin around by just pointing. There's more research I think could be done. I was limited by time and participants. They all sort of lived in the area or within 5 miles. They had various depths of knowledge of the area, but I didn't ask that question very well, so I don't know which did and which didn't. And I think people that were very new, have never seen the area, have been there a week and a month, would be good to look at. Also, so I was from computer science, so there are other uses that should investigate it, such as education, using it in the classroom. I was going to try and use it with some kids, but sadly they then got busy and couldn't make it. And so one of the participants was a teacher, and they had some good comments of, well, this would be good for kids learning about their area because they're less likely to get bored, and you can get a group around it, as I said. So yeah, there are some image credits, and if you want to contact me, please do info@livingwithdragons.com or Twitter, or ask me later on. It'd be great. I've got no plans to do any further research on this myself, but the paper will be in the proceedings of the conference, and I've got the other 2 papers I did for my degree with more detail, so if anyone's interested, it would be great to hear about that and to help you out. Okay.
Thank you. So we have time for questions. Two questions. First is, how long does it take to make this model, this white model? And the second is, would it be possible to use the results of the Fatbeing 3D printing community who are doing physical objects from computer models?
So, sorry, that's something I forgot to talk about. I looked at the pictures I showed of where they make the physical models, and they're a bit bigger, but sort of the papers I read said 150 people took 11 days, which is quite a lot. I actually used the projector just projecting onto the card that I was cutting out of to trace the lines, which made it quicker. And so I took about 8 or 9 hours by myself waiting for the glue to dry. Obviously you could develop software to take the contours and put it straight into a 3D printer, or at least a machine cutter or something. So I think it's a lot quicker to do it. And obviously you don't have to do the painting, you can just bring in the model you've made of different areas and switch it in and out. Another thing I kind of thought about is a dynamic model of some sort. If you've got, it probably won't be great resolution, but if you've got blocks that can move up and down to change the hill, so you can press a button and it's a different area. So yeah, it definitely could be done on machine cutters a lot faster, but I was faster than other people.
Do we have more questions?
No? Okay. So thank you, Gregory.